Hey there, welcome back to Pi Basic Math, and this is still algebra, and this is the third lesson. We'll be talking about, we'll be continuing with our equations. Okay, last lesson there was a particular simultaneous equation that I said we were going to come back to check. So this particular equation was solving two unknowns simultaneous equation. So what we got, the answer we got is actually very correct, right? Answer we got was actually very correct. We got our x to be, we got our x to be 11 over 5 and our y to be minus 3 over 5. Okay, minus 3 over 5 and 11 over 5. So we're actually very correct. While checking the mistake, I made a mistake, I'm very sorry for that. The equation 1 should be x plus 2y. Where we're trying to check, I said x plus y, so it's actually x plus 2y. Okay, so if you say x plus 2y, you realize that what you have here will be plus here, right? And this will be minus 6 over 5, which will actually give us 15 over 5, and that is equals to that which will actually give us not 15 over 5, I mean, pardon me, 11 minus 6 is 5 over 5, which will give us 1, and that is what you have in this place here. Okay, so it is very correct. And now let's move on with today's lesson. So we want to talk about quadratic equation very shortly, after which we'll come back to simultaneous equation involving three variables. Let's say you have x, y, and z. Okay, let me just sharpen this a bit so we can see it better. All right, now so we say a lot about quadratic equations, but do we really know a lot? Okay, so understand what is going on here. We need to understand first, from the last lesson or 2 lessons ago, we said that whenever you have an equation of this form, okay, we said that this degree of 2 here symbolizes it is quadratic, right? So we said a must not be equals to 0. You can go and watch it for previous lesson to recap. All right, so now we want to solve quadratic equations, but for us to solve quadratic equations, we must understand that there are various methods for us to solve them. Now the first method to solve a quadratic equation, let me start on a fresh page. Okay, sorry, I feel like this is still a bit thin. Yeah, so the first method one could use to solve your quadratic equation is what we call the factorization method. Okay, factorization method. Now what is this method about? Right, now let me quickly give us an example, or let me use the general formula. So ax squared plus bx plus c, all right, let's say equals to 0. So this is the general will represent our quadratic equation. Now for us to use the factorization method, one thing you must first take note of is that you need to first look at what you are trying to find, which is that you need to first multiply the coefficient of x squared and the coefficient and your constant here, so AC. So this is what we want to check out. So we're looking for two numbers that when we add them up, we'll get AC, and also when we multiply them, we'll get the same AC. So that's the idea for factorization. Once you can get that, the next step is you split those numbers, right, to get the numbers you have here. You split them and give each of them a value of x. So let's just give an example. Okay, so that will just further simplify all what I've been saying, right? Because if you if you understand the concept and you don't solve questions, it might be like you even don't understand the concept. So let's see a first example. All right, so if you ask to solve this quadratic equation, if you ask to solve look at this, x squared minus x minus 2 equals to 0. Now if you ask to solve this particular quadratic equation, like I said, the coefficients of x squared and the constant you have here, you need to first multiply them. So if you multiply these guys, this is like saying 1 times negative 2, right? And this will give us negative 2 minus 2. Now you're looking for two numbers that when you add them up, are you with me here? Okay, so when you add those numbers up, you would have, looking for two numbers. Yes, you're looking for two numbers that when you add them up, sorry about the statement I made here. Okay, that was a blunder, sorry. So when you add those numbers up, two numbers, right, when you add them up, you get what you have here. All right, now you know what you have here is negative 1, right? So I mean the coefficient. So if you add those two numbers, you get negative 1 here. and when you multiply them, you get negative 2. Alright, so that's what we are looking for. Don't worry, don't feel burdened up. Alright, there's a way to actually find those numbers. So you just remember your LCM. That's the easiest way to go about it. Remember your LCM. Okay, so if you try 1 now here, what will you have? I believe you have 1. Is that not so? Sorry, you have 2. My bad. If you have 1 here, that's 2 divided by 1. You have 2. Is that not so? Okay, now if you have this, this is the way we go about it. You take them diagonally, so which means that 2 and 1 are the numbers that you could have to get 2. Is that not true? I would later add the negative sign, but 2 and 1 are the numbers that you could multiply to get 2 and add to get 1. But you now write your 2 and 1 in this way, such that the next thing you want to do is you allocate a convention in a sign to either of this number. Now you clearly know that you want 2 numbers that when you multiply you get negative 2. Is that also? So I can either say minus 2 and 1 or 1 and minus 2. These are the possible numbers that if I multiply them, I will get a product of minus 2. Is that not so? Alright, now don't forget the second rule. The second rule is you are trying to look for 2 numbers that when you add them up, you get a negative 1, minus 1. Now if you add minus 2 and 1, this will give us sorry. What I wrote here is the same thing as what is on top here. So the second one could be minus 1 and plus 2. Okay, minus 1 and plus 2. So if you add these two guys, you get a negative 1, which is what we are looking for. However, if you change it and you say minus 1 and 2, if you add these two guys, you get 1, which is not what we want. Although it satisfies the 2 numbers that you multiply to get what you have here, but it doesn't satisfy what you have in this middle. So these are the numbers that we are looking for, minus 2 and 1. So once we have gotten these numbers, the next thing you want to do is you attach x to them, right? Because if you attach x to them, you'll be able to split them. You'll be able to get what you have here, basically. So if you attach negative, let's say you attach x to them, this is like saying minus 2x plus x. That also, and this will basically give us negative x, and that is what you have in this part here. Do you understand what I'm saying now? Alright, so your quadratic equation now becomes x squared minus 2x plus x minus 2 equals to 0. Okay, can you see this now? So this is factorization method. So the next thing is basically using the word itself, factorization. So what do? If you look at x squared and 2x, they have something in common. Okay, the highest common factor actually, which is x. So if you factorize x from here, what you have left is x minus, if you factorize x from here, what you have left is just 2. Okay, and then plus, what's the highest common factor here? Is clearly 1. There's 1 here, there's 1 here. I mean 1 times x is x, 1 times minus 2 is minus 2. So you factorize using 1, you just have what you have again, x minus 2 equals to 0. So this is factorization method. You see x minus 2 and x minus 2 are both occurring here, so we can now factorize them, which will be x plus 1 and x minus 2, or x minus 2 and x plus 1, does not matter, equals to 0. Alright, the reason why it does not matter is that, don't forget, in the lesson 1 of our algebra, we said AB is the same thing as BA. Okay, your multiplication is commutative. Alright, so it does not matter if x minus 2 comes first or x plus 1 comes first. So at the end of the day, your values of x would be 1 and 2. Alright, sorry, negative 1 and positive 2, because what next thing to do is just set your factors to 0. If x plus 1 times x minus 2 is 0, it means that x plus 1 or x minus 2 is 0. That's what it means. Or you could say and, does not matter. The point is that both would be 0, right? If both would be, each of them would be 0 if the multiplication of them is 0. We could say that. That's what I'm saying. So if you set this to 0, this will be minus 1, and if you set this to 0, this will be 2, and that will be the solution to this quadratic equation here. Alright, now next thing to do is now this same equation you have here, we want to use another method to solve it. Alright, so we'll solve with the other methods that we'll be discussing in this lesson, after which I'll give you guys an exercise. I'll give you an exercise, alright, for you to try. And once you try that exercise, you'll be able to, you pause the video, alright, so you pause the video and try it on your own. using the three methods. If you get it, that means you're following, and you should like and subscribe, and then comment if you're learning. All right, so let's see the other methods that exist. So the second one, that's factorization. The second one is completing the square. All right, completing the square. Now, completing the square method actually works for any kind of quadratic equation. Yeah, I need to mention that there's a clause. All right. Now, your factorization method, as we said it here, sorry about that. Your factorization method, okay. Your factorization method. Please take note that your factorization method, your factorization method only works for some situation. It doesn't work for every kind of quadratic equations. So you must take note that it's not every quadratic equation you can solve using factorization method. You need to take note of that. All right. So let's see completing the square method. We will solve the same equation using completing the square method. So we said x squared minus x. Let's quickly check that. Minus x. X squared minus x minus 2. Okay. Equals to 0. Alright, so to solve this using completing the square method, what you need to first do is, has been done actually, ensure that the coefficient of x squared here is 1. Ensure that before you proceed. Once you have ensured that fact, then the next thing you want to do is take every constant to the other side. So the constant you have here is just 2. So we have x squared minus x equals to 2. Now the next thing you want to do is you are going to look at the coefficient of x. What's the coefficient of x? You know it's negative 1, right? Minus 1. So plus, what you're going to do is you're going to add to the coefficient of x, you divide it by 2 and you square it. Since this is an equation and we don't want to tamper with it, right? So for us to leave it as it is, right? You do what you've done to the left, also to the right hand side, okay? Then you also add to the right hand side minus 1 over 2 all squared, okay? Let me come again. What did we do here? You look at the coefficient of x, which is minus 1. You divide it by 2 and then square it. So because an equation, like I said in the previous lesson, that for an equation, what you do on the left, you must also do on the right. Is that not so? Alright, so for that to be established, for us not to tamper with the original equation, this that we just introduced, what did we do? Whatever the coefficient of x is, be careful, the negative sign matters. If it's minus, put your minus. If it's plus, of course, plus. But then be careful, your minus must come to play, alright? So whatever the coefficient of x is, divide it by 2 and then square it. So you do what you've done on the left to the right. So if you do this, you will complete the square here, alright, by saying what you have here is the same thing as x minus 1 over 2 all squared. Now if you decide to expand this, you will get this back. You can try it. If you decide to expand this, you will get this back. So that's the idea. So this will be x. You just pick the x, then you pick what is in bracket, then this square that are on top of them, they share the square. Alright, so on your right hand side you have 2 minus 1 over 2 all squared is plus 1 over 4. So this will be x minus 1 over 2 all squared equals to, your LCM here is 4, right? And this will be 4 times 2, which is 8 plus 1, and this will be equals to 9 over 4. So your x minus 1 over 2, since we have an equation such that you have square on the left, what you just need to do is take the square root of both sides. So if you take the square root of both sides, don't worry, in the next lesson we'll talk about powers and roots. You'll be able to probably understand very well what I mean by taking the square root of both sides. So if you take the square root of both sides, you will have the square root here gone, and then you have now you must take note of something. When you're taking the square root of a number, alright, so it's important that you put plus or minus. I'll quickly explain why. Square root of 9 over 4. So this is what you have on the right hand side. You just take the square root of both sides. So the square root here is gone because the square root of a number is simply that number raised power half. So if you multiply this by half, you have just 1, and then this guy raised to power half, which is the square root of this guy. Now I said, why do we include plus or minus whenever you're taking the square root of a number? Now let me explain. If I say that if I tell you that x squared equals to 1, just look at something as basic as this, and I say that x equals to, and I say x equals to root 1, this is correct, right? And x is 1. But I hope you know that x equals to 1 is not the only solution that satisfies this equation. Why is that so? Check the previous lesson. I made emphasis on the fact that when you have a quadratic equation, or you have an equation of degree 2, you expect two solutions. I guess I have not mentioned it yet. I was talking about simultaneous equation, that when you have two unknowns, you need two equations. When you have one unknown, you need one equation. But in this case, let me just emphasize that if you have a linear equation, right? A linear equation, I mean an equation such that you have x to the power 1 as the highest degree, you expect one solution. If you have a quadratic equation, just one quadratic equation, such that you have the degree of x to be 2, you would have two solutions. If you have a cubic equation and so on and so forth, you have three solutions. So in this case, since you have x squared to be 1, you would need to have two solutions, or you definitely have two solutions. So for that reason, like I said, x equals to 1 is not the only solution of this. Why is that so? Yes, if you try to check it, if you put 1 here, right, you have 1 squared, which is what? 1. But it's not only 1. Minus 1 also satisfies this. How? If I put minus 1 into this equation here, that means if I have minus 1 all squared, this is actually still 1, which satisfies this equation likewise. So whenever you're taking the square root of a real number, or even a complex number, doesn't matter. Once you're taking the square root of a number, when you're taking the square root of a number, even a complex number, I'm right. So you just need to include the positive or negative, alright? So which means that you have positive or negative 1 as your solution. So with that knowledge being established, let's come back to what we're solving. Now from what you have here, your x now will be equals to 1 over 2, right? 1 over 2 plus or minus the square root of 9 is 3, square root of 4 is 2. So what you have here is just 3 over 2. Again, we'll talk about this in the next lesson more deeply, so you can understand powers and roots. I hope you're learning. Now moving on, your x now will be equals to 1 over 2. Now since it's plus or minus, this means that you have 1 over 2 plus 3 over 2, or 1 over 2 minus 3 over 2. Alright, so your x now will be equals to LCM 2, numerator you have 1 plus 3, or LCM 2, numerator 1 minus 3, and your x now will be equals to 4 over 2, or minus 2 over 2. So your x will be equals to 2 or negative 1. Alright, and that was exactly what we got in using factorization method. Let's look at it. Look at it here. That's what we got here. Look at it. Minus 1 and 2. We also got minus 1 and 2. So you can see that factorization method is not only the method that we use to solve quadratic equation, we also have computing the square. I hope you understand this. Alright, so put in the comment section your questions that you might have. Now let's look at the third method for the purpose of this lesson. Third method in which you can solve a quadratic equation is what you call your quadratic formula. Now I will not just give you the formula, I will actually prove the formula for you, and then I'll give you the formula. But what you are interested in actually is just what the formula is. You don't necessarily need to be proving the formula when you want to use it. Just recall the formula. Now in the Nigerian educational system, some people know the quadratic formula as almighty formula, and that's because it solves every form of quadratic equation that you might want to solve. Actually, even your computing the square, like I said, also solves it, and you will see why that is so, because actually your computing the square method actually is what led to your almighty formula. Alright, so let's see. Now if you have y equals to ax squared, let's write the general formula of a quadratic equation. Y equals to ax squared, plus bx plus c. Now this is the general quadratic equation formula. Is that not so? Alright, and we said to solve this, we should set y to 0. So that means you have ax squared plus bx plus c equals to 0. Now from what we discussed. You're just going to basically apply the same principle that we applied for completing the square method. And what did we do? You divide through by a, right? You want to make sure that your x squared here has a coefficient of 1. So you divide through by a, and that would be you divide through by a, you have x squared plus bx over a plus c over a equals to 0 by a, which is just 0. Then take every constant to the other side. The only constant we have here is c over a. Is that so? The constant is that number, that real number you have that does not have your variable attached to it. Alright, so minus c over a. Now the next thing we want to do is the completing the square idea. What did we say in completing the square? We said we should take the coefficient of x, divide it by 2, and then square it. So that's b. Don't forget that b over a is the coefficient of x here. So just divide it by 2, that is 1 over 2 of this, then square it. Alright, so then since an equation, what you do on the left you must also do to the right hand side. Okay, what you do on the left you must also do to the right. So this will give us x plus, to complete this square, I believe you already know the procedure, plus b over 2a all squared. That's what we did in the previous example. And this will give us minus c over a plus b squared, right, over 4a squared. When you square b, you have b squared, and when you square 2a, you have 4a squared. I hope we are learning. Alright, so the next thing to do now is this will be x plus, let's quickly simplify what you have on the right hand side, x plus b over 2a all squared equals to, the LCM here is 4a squared, okay, and then what you have in your numerator would be minus 4ac plus b squared, but this can be written as x plus b over 2a all squared, okay, equals to your denominator you have 4a squared, and this will be b squared minus 4ac. All right, now from here you can take the square root of both sides, right? This will be x plus b over 2. I hope you have not forgotten what I said when you're taking the square root of both sides. What do you do exactly? You add plus or minus. All right, square root of b squared minus 4ac. I'm sure it's looking like something you've seen before if you are familiar with quadratic equations. So your x now will be equals to minus b over 2a, right, plus or minus your square root of b squared minus 4ac. But don't forget that in your denominator you have the square root of 4a squared. So the square root of 4a squared is just 2a. So your square root will only be what you have in your numerator. So you have your LCM to be 2a, and what you have in your numerator will be minus b plus or minus square root of b squared minus 4ac. Okay, and this is the value of your x. So whatever question you are given, you can always have two solutions, due to the fact that you have a plus or minus here. That is minus b plus whatever you have, or minus b minus whatever you have. So this is the quadratic formula. This is the third way in which you can solve a quadratic equation without having to go through the exercise of completing the square. You can just recall your formula and then plug in what your a is from here, that is the coefficient of x squared, what your b is coefficient of x, and what your constant c is. Plug it into this place and you get your values of x. So let's solve the same example again using the quadratic formulas. Because the example we gave was x squared minus x minus 2 equals to 0. Now let's derive our constants. Your a here is 1, your b here is minus 1, and your c is minus 2. So what would be your x? Recalling your quadratic formula, you will have, this is minus b, right? So but your b is minus 1, so that's like minus into minus. Now I always tell my students that whenever you are solving questions, a mathematical question or any question at all that involves heavy algebra, you must be careful of this negative sign. Positive signs are actually very, what's that word now, are very lenient with your mistakes. You could make some mistakes, positive signs would chest it, I'm going to say that word, would absorb them. But when you have negative, your negative play a lot of pranks on you. The negative signs, they play a lot of pranks on you. So it's important that you are very careful. I even tell people to first take a deep breath once you see a negative sign, because it plays a prank on you. So look at this carefully. A student would have made a mistake here having to just write minus 1 because b is minus 1 and this formula says minus b, so that's minus into minus 1. All right, plus or minus now. Okay, square root of what's your b squared? That's minus 1 all squared minus 4 into what's a 1, what's b minus 2. Okay, divided by 2a, 2 into 1. So your x now will be equals to 1 plus or minus the square root of minus 1 squared is just 1. Then 1 times minus 2 is 2, right? Is minus 2. So minus times minus, which is plus. So that will be plus 8 here over 2. Sorry about the long square root sign. So your x now be equals to 1 plus or minus square root of 9 over 2. And don't forget that the square root of 9 is 3. So this is 1 plus or minus 3 over 2. So your x now will be equals to, let's split it, 1 plus 3 over 2 or 1 minus 3 over 2. Okay, so this means that your x will be equals to 4 over 2, right? And 4 over 2 is just 2, or minus 1 minus 3 is minus 2, so minus 2 over 1 is minus 1. And this is the exact same solutions we got consistently when we used factorization and also when we used completing the square method. So we see that quadratic formula is even a shorter method because see what we did, just one line, just one space in that sense, just a single page. All right, so let's finally try out something ourselves. I'll give us you can just pause the video, okay, and try it yourself. Let me give you an example, after which I'll then solve it and then we'll move to the next subtopic for equations. Now, if you want to know more about quadratic equations, because I believe you know that this is not all about quadratic equations, you have symmetric properties of root, alpha, beta. You remember? Yeah, we have alpha, beta, and you might want to also learn about alpha, beta. Okay, if you want to do that, please let me see your comments in the comment section if you want to know that, and also some other things. All right, because I actually hold lessons, tutorials, paid tutorials for people. So if you want to know any particular topics more in depthly, you can always put that in the comment section, and I'll put you through any topic that you want. Okay, now let's see something. Let's try something ourselves. So look at this exercise. All right, exercise. Now try this out. What if we are given to solve quadratically, of course, 2x squared plus 5x minus 3. Okay, I know you're saying I solved the one without without a number. I solved the one with just 1 and I'm giving you the one with 2. Well, I'll solve it here right and direct. So it's not an exam question like many some lecturers or some teachers do. They give the simple example and then they give you the hard exam. Okay, don't worry, I'll solve it here, but just try it. Okay, just try it. You can pause the video. All right, so continuing to solve this, what do we need to do here? If you want to use factorization method, let's say method 1, I want to use factorization method. So what did you say about factorization method? Let's call it FM, factorization method. So we said that all you need to do is you look at the coefficients of x squared multiplied by the constant you have, and you see you try and find two numbers that when you multiply you get this. When you add, you get what you have here, coefficient of x here. Okay, so 2 times minus 3 is minus 6, right? So let's look for two numbers. Let's do what I said we should be doing. So you do your LCM, try it with 1, always start with 1. So if you do 6 divided by 1, what you get here is what? Sorry, yeah, what you get, oh sorry, you can try with 2, start with 2 instead, start with 2. So if you start with 2, you have 3, is that not so? You have 3. Now if you look at it diagonally, 2 and 3 are two numbers and when we multiply it will give us 6, right? But we want a negative 6. So let's see if we can manipulate that. let's see if you can manipulate that. All right, so it's important that I take you through this process so you can understand the rigor. So if you choose 2 and 3, yes, 2 and 3 should give you 6. That also, yes, it should. Now if you try minus 2 and 3, you gave me minus 6, right? And 3 and minus 2 also, 2 and minus 3 also would give you minus 6. But if at all it satisfies this, it must also satisfy the coefficient of x here, right? So which means that you will need to basically also test to see if these two numbers we have chosen will give us 5, and there is no way in the world to give you 5. Minus 2 plus 3 is 1. That's not 5, which is not equal to 5. So this number would not work. Minus 2 and 3 pair would not work. If you look at 2 and negative 3, that is 2 plus negative 3, this will give us negative 1 minus 1, and this is nowhere in the world equals to 5. So which means that also 2 and minus 3 pair would not work. So you go back to your LCM table, you try 3. Now if you divide this by this, you have 1, right? So if you try this diagonally, this is 6, right, and 1. So let's try that pair, 6 and 1. I hope you agree with me that if you multiply 6 by 1, you obviously get 6. So for you to get minus 6, you need to put minus in one of them. So minus 6 and 1, or 6 and minus 1. So let's see, it satisfies this, right? Let's see if it satisfies the coefficient of x, which is 5. If I have minus 6 plus 1, what will I get there? I'll have minus 5. And this does not satisfy, it's not equal to minus 5. Let's try 6 and minus 1. That will be 6 plus minus 1, which is 6 minus 1, and that will give us 5. So yes, and this is equals to what we are looking for. So this pair is our this is our answer, or this pair is what we need. So 6 and negative 1. Don't forget the process. The next thing is to attach x to both numbers. So that means your equation now becomes 2x squared, okay, plus 6x minus x. Be careful, it's a negative 1, so you must have negative your variable as well, minus 3 equals to 0. Okay, now if you have this, this means that you now have you can now factorize. If you look at 2x squared plus 6x, what is the highest common factor here? 2, of course, and x. So that will be 2x is the highest common factor into what? X plus 3. Right? If you open this back, you get this. That will be 2x squared plus 6x. Then minus 1. In this case, minus 1 is your highest common factor. Then you agree with me that what you would have in your plus 1 rather. Pardon me. Yes, that's correct. So minus 1 would be your highest common factor. Then what you have in your bracket will just be x plus 3. Yeah, I was correct initially, sorry. And this will be equals to 0. So if you compare what you have here to what you have here, it's the same thing when you open the bracket. This will be minus x minus 3. Now you can see that these brackets are the same. That's the aim. Once this is established, then you can now say 2x minus 1. You can now put them in factor side by side, and x plus 3 equals to 0. And this means that your 2x minus 1 is 0, or x plus 3 equals to 0. And this implies that your 2x is 1, or your x is minus 3. You already found one of the values, and here your x is half, 1 over 2, alright, or minus 3. So these are the values of x that you have to solve this equation. Now I trust that we can use quadratic formula to do it, but well, since we are doing the correction, so it's important I'll do it for us. Alright, so do not fret. So let's first use computing the square method and also use quadratic formula before we move to the next subtopic, which is solving simultaneous equation whenever you have 3 unknowns, that is 3 equations. Now look at this. So let me move back to see the equation was solving. Okay, 2x squared plus 5x minus 3. So 2x squared, using computing the square method, 2x squared plus 5x minus 3 equals to 0. So using method 2, let's say M2, method 2. What do we do? The first thing, like I said, is to make sure that you isolate x squared. Let the coefficient of x squared be 1. For us to establish that, we need to first divide through by 2, and this will be x squared. Dividing the entire equation by 2, we have x squared plus 5x over 2 minus 3 over 2, okay, equals to 0. 0 over 2 is just 0, sorry. So from here, you want to isolate, you want to ensure that all the variables are what you have on one side, constant on the other side. So this will be plus 5x over 2 equals to 3 over 2. And the next thing will be, this will be x squared plus 5x over 2 plus, don't forget what we said, the coefficient of x is 5 over 2. So you divide it by 2, which will be 5 over 4. That's like saying 1 over 2 times 5 over 2. That's 5 over 4 all squared equals to 3 over 2 plus 5 over 4 all squared. And this will be x plus 5 over 4 all squared, which will be equals to 3 over 2 plus 25 over 16. And this will be equals to, the LCM here will be 16, right? And then you have 8. 16 divided by 2 is 8. 8 times 3 is 24 plus 16 divided by 16 is 1 times 25 is 25. So this will be x plus 5 over 4 all squared equals to 24 plus 25 is 49. So we have 49 over 16. And this will be, you can now take the square root of both sides. So you have x plus 5 over 4 to be equals to, don't forget what I said, plus or minus, okay? Because we're supposed to have two solutions. So this will be equals to plus or minus, the square root of 49 is 7, square root of 16 is 4. Okay, moving on. This means that your x plus 5 over 4 is now equals to plus or minus 7 over 4. Many students would definitely not use the completing the square method. They would rather just stick with algebraic formula, quadratic formula. If of course you can remember that, fine, good for you. But I actually prefer the completing the square method. I like that stress that it takes me through. Okay, it makes me on a go. I like that stress. So x equals to minus 5 over 4 plus or minus 7 over 4 plus or minus 7 over 4. So your x now will be equals to, let's split it. So you have your x will be equals to minus 5 over 4 plus 7 over 4, or minus 5 over 4 minus 7 over 4. So your x now will be equals to, your LCM is 4, okay, and this will be minus 4 plus 7, okay, or your LCM again here 4, which is minus 5 minus 7. So your x will be equals to 2 over 4, and I believe we got half using factorization, so we are very correct. And minus 5 minus 7 is minus 12 over 4. So your x will be equals to 1 over 2 or negative 3, okay, or minus 3. So let's see if we are in sync with what we got here. Can you see? It's the same thing, minus 1 over 2 and minus 3. So finally, let's use completing this. Let's use our method 3, which is the algebraic formula method. And what's the method? Okay, let's first write our equation. It was 2x squared plus 5x minus 3 equals to 0. So using your quadratic formula, we said our x will be equals to, I hope you've not forgotten, minus b plus or minus plus or minus b plus or minus square root of b squared minus 4ac over 2a. Okay, so what you want to do is declare your constant first. Your a is 2, your b, I believe you know how to go through those constants. Just compare what you have here, compare it to the general formula ax squared plus bx plus c equals to 0. This is the general formula of quadratic equations. Okay, and then your x now will be equals to, alright, so x will be equals to, b is 5, so that will just be minus b, minus 5 plus or minus square root of 5 squared, okay, minus, there's no minus here, so you have peace of mind. Your a is 2 and then your 3 is negative, so your c is negative 3 divided by 2a, a is 2. So your x now will be equals to minus 5, right, plus or minus square root of, this will give us 25, right? This is 25. 2 times minus 3 is minus 6 times minus 4, that's plus 24 over 4. So you can already see that it looks like what we were getting here in our computing the square. Remember we had something like this, so you see that they're actually in sync. Method 2 and method 3 are basically the same thing. Alright, so x equals to minus 3 plus or minus what you have in root 49 all over 4, and this will be equals to minus 3 plus or minus 7 over 4. So if you solve this at the end of the day, you get the same thing that we got in this place. I should continue, Abby. Okay, let's continue. Sorry. We hope we are following. Okay, I hope so. So this will now be your x now will be equals to minus 3 plus 7, minus 3 plus 7 over 4, or minus 3 minus 7 over 4. Oh, sorry, not minus 3, this is minus 5. Okay, sorry about that. It's your b, it's minus 5, not minus 3. It's minus 5. Let's correct that. It's minus 5. Minus 5. Okay, so your x now will be equals to 2 over 4 or minus 2 over 4, which is basically what we got in the previous method. So 1 over 2 or negative 3 would be your solutions. So that's that for the purpose of this lesson. That's that about quadratic equation. Don't forget I said there are obviously a lot more things to learn about quadratic equation, but we would stop there. Now let's go on to simultaneous equation. Now let's look at simultaneous equation. Simultaneous equation given 3 unknowns. Simultaneous equations, okay, with 3 unknowns. With 3 unknowns. Alright, so let's see, how do we do that? Now the way to go about that is this. We could use substitution method or elimination method, right? But then sometimes substitution method might be ambiguous if you have some ambiguous kind of things, but then elimination method would most times be easier to manipulate or to analyze. So let me just give us examples basically. Okay, let me just give an example that will illustrate what we're saying. So solve the following system of equations. Solve the following system of equations. All right. So what system of equations are we talking about here? All right, so look at this. Let's say example 1. You do the second one yourself. Okay, pause the video and try it yourself. So look at this. So imagine you are given x plus y plus z equals to 0, and then x minus y minus z equals to 1, and then you're given x plus y minus z equals to 1 as well. Now to solve this simultaneously, you pick each pair of equations. Okay, you pick each pair one after the other. Let's say this is equation 1, equation 2, and equation 3. Now for equation 1 and 2, if I pick equation 1 and equation 2, what do I mean? Look at x. Let's say we want to eliminate x. We can actually eliminate any of these guys because I mean their questions are the same. If you were following, if you understood the previous lesson, you should know what I'm talking about. Alright, so you can go back to the previous lesson to see what those 2 unknowns look like before having to watch 3 unknowns. Now if you have to solve this system of equations, let's decide to eliminate x, so you can see what I'm saying. So eliminate x, what do you need to do? So you say equation 1 minus equation 2, that eliminates x automatically. Alright, so if you do equation 1 minus equation 2, x minus x is gone, then y minus minus y minus minus y, which is 2y, then plus z minus minus z, and this will be equals to 0 minus 1. So this will be 2y plus 2z equals to minus 1. Let's call this equation 4. Keep it somewhere. Now you also pair equation 2 and 3. Okay, if you pair equation 2 and 3, we can do the same thing there to eliminate x again. So you can do equation 2 minus equation 3. If you do that, you will see that x is gone again, and then you have y to be minus 2y, because this will be I'm skipping a step, sorry. This will be minus y minus plus y, which is minus 2y, then minus z, right, minus minus z, which is 0 actually, minus z minus minus z, that's minus z plus z, and that's 0. So that means that minus 2y equals to 1 minus 1. 1 minus 1, what you have on the right hand side of both equations, and this is equals to 0. Now this clearly states that your y is 0, because minus 2y equals 0. If you divide through by minus 2, you find out that your y is 0. Now if you have solved for y, it's easy to solve for z. Just plug in your value of y back into equation 4. Let's see that. If you plug your value of y back into equation 4, alright, so you have instead of 2y, I will have my equation 4 to now become, my equation 4 will become 0, right, because 2 times y, which is 2 times 0 is 0, plus 2z equals to minus 1, and that means that my z will be equals to minus half, minus 1 over 2. Now we are not done. We have found y and z. Then what about x? To find x, just use one of the equations. You can use 1, you can use equation 2, you can use equation 3, either one of them. Now if you use equation 1, believing that this system of equation is consistent, okay, so that's why you can use any one of them. Now the idea of consistency is actually an advanced concept, okay, so I might not exactly fully explain it here. Alright, if you want to know the concept, you can of course register for a one-on-one tutoring session. I would talk about it in a more full-blown manner. Alright, so x plus y plus z equals to 0, x plus y plus z equals to 0 is what you have here, right? So you want to look for the value of x, so that will be x equals to minus into y plus z, right, which is like minus y minus z. So you don't get it twisted. Just take y and z to the other side, so you have negative of both y and z. But the value of y is known to us to be 0, and the value of z is known to us to be what? Negative half. So that means that your x will just be positive half, 1 over 2, because minus times minus is plus. So that means that your values of x, y and z is actually equals to 1 over 2 comma minus 1 over 2, sorry, comma 0, pardon me, comma 0, your y is 0, comma minus 1 over 2, respectively, obviously. So your x is half, your y is 0, and your z is minus half. I hope we're learning. Alright, so now let's take an exam. Let's take an exercise. Try this yourself. You can pause the video, and if you're not getting this, just play it to see what the solution is. So exercise. So we're supposed to solve simultaneously this equation. Exercise. So solve simultaneously. Okay, solve simultaneously. What are we solving simultaneously? Look at this, 3x. Yes. I'm giving you the much technical one. Don't worry, we'll solve it together. Actually, you should get used to solving problems, because don't always be spoon-fed. You want me to solve the hard ones and give you a simple one. Now you won't learn that way. So you need to actually learn the hard way. Okay, x minus 3y plus z equals to minus 1. Okay, so solve this. You can pause the video and play it back when you're done with your solution. Minus 1, please. Okay, now to solve this, let's declare each variable. Let's define each equation. So equation 1, equation 2, and equation 3. Now from the same method that we used, although this time around your x, you're using elimination method, okay, although your x in this case, if you look at equation 1, your x is 3, so you can't do equation 1 plus equation 2 just like that, except you first multiply equation 2 by 3. I believe you remember we did it when we had two variables or two unknowns. Now if you do equation 1, if you add equation 1 to equation 3, that will eliminate x for us, I believe. Alright, so it will eliminate x for us, and that will be minus x plus x, that's gone. Then you have y minus 3y. Why did I write minus 3y? No, it is y plus minus 3y, which is still minus. Okay, then plus 2z plus z equals to 2 minus 1. Okay, and this will give us minus 2y plus 3z equals to 1. So we can call this equation 4. Now that we have done that, we need to also take another pair. Okay, so we can take equation, say maybe equation, okay, for the previous example, for the question I solved in the one I just solved, I took equation 1 and 2 and equation 2 and 3, but this time around I want to change it to equation 2 and 3 and equation 1 and 3, so you don't get too used to saying okay, that's be 1 and 2, 2 and 3. Okay, it can be 1 and 2, 1 and 3, it can be anyway, as long as you are taking two pairs. All right, two different ones. Now let's try to pair equation 1 and 3, but before we can pair them to eliminate x, you agree with me that you can't add them up, it will eliminate x. Look at it, x here is having a coefficient of 3, x is having a coefficient of 1. So for us to eliminate x, we need to look at this equation 3 and multiply it by 3. So if I multiply equation 3 by 3, that would make this x here to have the same coefficient as the x in equation 1. So let's do that. 3 is scalar 3 multiplied by equation 3. What will you have? You will have 3x minus 9y plus 3z equals to negative 3, and we can call this equation 5. Okay, now for what we have here, we can now pair equation 5 with equation 1. How? You can just say equation 1 minus equation 5. Once you do that, we have eliminated x, so that will be 3x minus 3x, which is gone. Then you have 2y, okay, minus 9y, right? Then plus 4z minus 3z, then this is equals to 1 minus 3. Now with this you have 11y, okay, you have 11y, then 4z minus 3z is that's plus z equals to 1 minus 3, that's equals to 4, because it will be 1 plus 4. So we can call this equation 6. Don't be troubled that we have 6 equations we are solving. No. Just make sure you follow the concept step by step. It is still quite basic math. Okay, so for equation, we can now pair equation 4 and 6. Why? They both have y and z. So it has sort of reduced your simultaneous equation having 3 variables to simultaneous equation having 2 variables. Okay, now to pair 4 and 6, we still have a problem here because you want to find one of the variables, right? 2 and 11 for y. Those numbers are quite strenuous for us to now easily use. That you can do them. You can eliminate y. Just what you just need to do is you multiply equation 4 by 11 and multiply equation 6 by 2. That would make us have 22 as our coefficient of y. But rather than doing that, I think it's best for us to eliminate z, since we just have 3 and 1. So all you just need to do is you multiply equation 6 by 3. So if you multiply equation 6 by 3, that is, if you have 3 times equation 6, you have this. You have 33y plus 3z equals to 12. Now if you do this, let's call this equation 7. Now if you do this, you will see that if you now pair equation 7 and equation 4, you realize that we now have 3z, so we can eliminate z by subtracting those equations. Okay, I hope you are learning. Alright, if you've not subscribed, you are wrong. You should subscribe to the channel. Alright, so we can now have equation 4 minus equation 7. Now if we do this, you have minus 2y minus 33y minus 2y minus 33y equals to, you agree with me that 3z minus z, 3z is 0, so I don't have to repeat that. So this will be 1 minus 12, right? 1 minus 12, okay, and this will be minus 35y equals to minus 11, okay, which means that your y will now be equals to 11 over 35. Why did I do that? Your minus, if you divide through by minus, your minus becomes plus. So minus 11 over minus 35 is just 11 over 35. We have found y. Now for us to find z, you just need to pick one of this equation. So from your equation 4, that can help you find z. Equation 4 says that 2y, or we can even use equation, anyone actually, you can use equation 4, you can use equation 6. But let's use equation 6, okay? Or should we use both? Let's use both to see if it is consistent. Alright. So let's see. Minus 2y plus 3z equals to 1. And you want to find what? You want to find what z is. That means that 3z is equals to 1 plus 2y. And that means that your 3z will be equals, so let's plug in our value of y. This is 1 plus 2 into what's y? 11 over 35, okay? And this will be 3z equals to 1 plus 22 over 35. 1 plus 22 over 35. So your z, your 3z will be equals to, if you use this, if you use your LCM here, your LCM is 35, and your numerator you have 35 plus 22, okay? Yes, it's long. Yes, it's long. 3z equals to 35 plus 22 is 57. Yeah, 35 plus 22 is 57 over 35. So your z will be equals to 1 over 3 into 57 over 35. Can 3 divide 57? Let's see. Without a remainder, let's see. This is 1 and this is 3. For the purpose of those that do not remember this, 9, and now you have 27. So yes, so if I divide through, if I use this 3 here, I will have 19 over 35 as my value of z. Now let's use another equation to see if it is consistent before we find the value of x, and wrap up this lesson on equations. So if you look at yes, where is that equation we wanted to use? Yes, equation 6. We said 11y plus z is 4. From equation 6, right? Equation 6, we said that 11y plus z equals to 4. So let's see if this will give us the same z we got here. This means that z is please, if you are solving a WAEC or a JAM question or some other question somewhere, you don't have to do this, okay? Just choose the equation that gives you your answer faster or easier. Right? So 4 minus, what is y? I think our y was 11 over 35. So that's 11 into 11 over 35. So your z will be equals to, what will be the LCM here? Your LCM is 35. And you have 35 times 4. 35 times 4 minus 11 times 11. Okay, so let's see what will be z. So basically your z now will be equals to 35 times 4. What's 35 times 4? I believe that is 0 to 12. I believe that's 140. Okay, that's 140 minus 11 times 11 is 121. alright, over 35. So your z will be equals to 140 minus 121. Okay, you can just use this 140 minus 121, and this is 3 here, 1, this is 9, 1, so this is 19 over 35. So you can see that these equations are consistent. Alright, so it's correct. Now finally let's find x. Alright, because we have found y, we have found z. So let's go back to one of the equations to find. So either equation 1 or equation 2, either equation 1 or equation 2 or equation 3, either one of them will give you what the value of x is. So let's look at the easier one. I believe equation 2 is the easiest, right? I believe so. So minus x plus y plus 2z equals to minus x plus y plus 2z equals to 2, minus x plus y plus 2z equals to 2. So let's see that minus x plus y plus 2z minus x plus y plus 2z equals to 2. Now since we have found y and we have found x, so I have found z, so basically x is easy to now find. So this will be minus x plus, what is y? 11 over 35, and your z is 19 over 35, and all this is equals to 2. So your x here, if you subtract 2 from both sides and add x to both sides, if you add x to both sides, your x here is gone, you have x on the right, and if you subtract 2 from both sides, your 2 here is gone and you have 2 on the left. So basically your x will just be equals to 11 over 35, okay, plus 2 times 19 is 38 over 35, okay, minus 2. This is what you have. 2 comes here, minus 2, x goes here, plus x. Alright, so solving this gives us x, okay. So your x now will be equals to, let's just pick or should we just do the LCM of everything? Let's just do the LCM of everything. The LCM of everything will be 35, as you can see. Then this will be 11 plus 38 minus 2 times 35, which is 70. So this will be equals to 11 plus 38 is I believe that's 49. So 49 minus 70. And what would that give us? Okay, 50 minus 70 is 20. That means that what you have here is minus 19 over 35. Yeah, 50. Yeah, I believe so. So this is your x. So it looks like your x and your z are negative of each other. So that means that your x comma y comma z for this simultaneous equation involving 3 variables will be equals to minus 19 over 35 comma 11 over 35 comma 19 over 35. So don't always expect your simultaneous equation to give you integers. Okay, as you can see, these are not integers, these are rational numbers. So don't always expect an integer. You want 1, you want 2, you want minus 2, you want, no, it could be fractions like this. It could be fractions, basically fractions like this. Fraction is the word, not just rational numbers, because 2 is rational number. All right, okay, and this could be written this way, for this one is just me playing around. Okay, 1 over 35 into minus 19 comma 11 comma 19. All right, so I hope you've learned something from equations generally. All right, so we've spoken about different kinds of equations and how we go about them. All right, so I would encourage us to go through the lessons again to gain full grasp of it, and make sure you look for questions. Be very aggressive about looking for questions. If you really are interested in making math quite basic for yourself, you must do well to find those hard questions. Go online, ask people around. You can even go and evangelize. Go from room to room and ask people if they have problems in maths and solve them. That's the way to go about it. All right, please, if you have learned one thing or the other, make sure you put in the comment section what you've learned, and also share with your friends. Let other people know about this. This gift that has come your way. All right, and then also like the video if you learned anything, and also do well to hit the subscribe button if you have not done so. Thank you for your time, and do have a wonderful day. Quite basic math.